In this video, we are going to see how to solve differential equations using Laplace transform. So first thing we have to note here is two formulas. One is for L of y dash of t, which is equal to s into y of s minus y of 0. Another is L of y double dash of t is equal to s square into y of s minus s into y of 0 minus y dash of 0. Here we are going to, in this video, we are going to solve second degree differential equation. That is the reason here I have taken only two formulas. One is for first order and then another is for second order. If we want to solve a higher order, differential equation of higher order like third order, fourth order, according to that we have to use the formula for third order, fourth order and so on. So here let us see what is the procedure to solve the differential equation using Laplace transform. Step 1 is first we have to take Laplace transform on both the sides to the given differential equation. Step 2 is apply the appropriate formula which is given here to formula number 1 and formula number 2. Next is step 3. We have to use the initial conditions given in the problem. Next step 4. From that we have to find y of s. And then step 5, after getting y of s, we have to take inverse Laplace transform on both sides. Then step 6 is we have to use the suitable formula to obtain the final solution y of t. So this is the procedure to solve the differential equation using Laplace transform. Now let us move on to the first problem. This is the first problem. Solve y double dash minus 3y dash plus 2y is equal to e to the power 2t given y of 0 is equal to minus 3 and y dash of 0 is equal to 5. So this is the differential equation and this is the second order differential equation. So the initial condition which I told you here that in step, so these two are the initial condition, y of 0 and y dash of 0. So here first let us start. Step number 1 is we have to take Laplace transform on both the sides. So here taking L of y double dash minus 3y dash plus 2y is equal to e to the power 2t. Sorry, here it should be L of e to the power 2t. We have to take Laplace transform on both the sides. So here since the linearity property is applicable, we can use the linearity property. We can split it as like this, plus 2 into L of y, right, which is equal to L of e to the power 2t. So now already we know the formula for L of y double dash as well as L of y dash. So we can use the formula here. What is L of y dash is s square into capital Y of s minus s into y of 0 minus y dash of 0. So this is the first formula for a second order derivative, minus 3 into L of y dash. So y dash means formula for first order derivative we have to use, that is s into y of s, that is capital Y of s minus small y of 0. So here capital Y and small y plays a different role. So you should be very careful in writing lowercase and uppercase alphabet. And then next term is 2 into L of y. This is a usual notation. L of f of t we can represent it as f of s. Similarly, L of y of t can be written as capital Y of s, which is equal to L of e to the power 2t is nothing but 1 by s minus 2. Right? This is the first step. That is second step. First step, taking Laplace transform on both sides. Then we have to use the appropriate formula 1 and 2. Then step number 3 is we have to use the conditions given in the problem. So these two are the conditions given in the problem. So we have to use those conditions here. So s square y of s minus s into y of 0 is minus 3. So already minus is here. We can write it as 3s. And y dash of 0 is 5 here. So we can write minus 5. And then here minus 3 s into y of s, and y of 0 is minus 3 here. Minus into minus plus 3 again into minus 3 will give you minus 9 plus 2 times of y of s, which is equal to 1 by s minus 2, right? So this is equal to here. Now we can simplify this, and from this what we are going to do is we have to find what is y of s. This is the next step. So y of s means actually here we can write y of s by taking as common term. We can write s square, and then here see here, this is the term containing y of s, y of s, y of s. So s square minus 3s plus 2, close the bracket. Apart from this, what are the things we are having here is plus 3s minus 14 minus 5 minus 9 is here, right? So this is a left hand side term, which is equal to right hand side is 1 by s minus 2. So this is 1 by s minus 2. Clear? So now we have to again take all the terms from the left hand side to the right hand side to find what is exactly y of s. So now we can find y of s. So here y of s into s square minus 3s plus 2 is equal to 1 by s minus 2 minus 3s plus 14. Right here to the right side we have to take LCM, and over the left side also we can factorize this s square minus 3s plus 2 as s minus 2 into s minus 1. So here finally what we will obtain here is this is equal to, after simplification we will get minus 3s square plus 20s minus 27 divided by, already here s minus 2 here in the denominator, and then this also will come in the denominator. So this becomes s minus 2 into s minus 1. So this is equal to minus 3s square plus 20s minus 27 divided by, this can be written as whole square into s minus 1. So the next step is we have to take inverse Laplace transform on both sides. So taking inverse Laplace transform, left side becomes L inverse of y of s and right side is L inverse of the remaining term. Whole square into s minus 1. So now you know how to find L inverse of this term. Okay, you can use partial fraction method or any properties, whatever method we have already studied, we can apply here to find what is L inverse. So that's it. If you apply the formula, we will be getting the L inverse. So that is the required solution. So here left side L inverse of y of s is nothing but y of t. So here while solving this, we used to get the solution to the differential equation. So now let us see how to solve or how to simplify the right hand side part. So here the easiest way is we can use partial fraction method. Partial fraction. Okay, using partial fraction, we can split it into, since the denominator is s minus 2 whole square into s minus 1. This is equal to, here if you notice here we are having two linear factor, one is repeated, one is not repeated. So totally three linear factors are there. So a by s minus 2 plus b by s minus 2 whole square plus c by s minus 1. So now we know how to find a, b and c. So by usual partial fraction method, we can find it. So b into s minus 2, sorry here, s minus 2 into s minus 1. Okay. Plus here b into s minus 1 plus c into s minus 2 whole square. So now by substitution method we can find what is a, b and c. So by substitution method, that is, here we'll be getting a is equal to, that is putting s is equal to 1 and s is equal to minus s is equal to 1 and s is equal to 2, and if we want we can substitute s is equal to 0 also to find the third value, right? So using substitution method we can get a is equal to 7, b is equal to 1 and c is equal to minus 10, right? So the question can be written as, that is, L inverse of minus 3s square plus 20s minus 27 divided by s minus 2 whole square into s minus 1. So this can be written as a is 7 here. So L inverse of 7 by s minus 2 plus b is 1. So L inverse of 1 by s minus 2 whole square plus L inverse of c is minus 10 divided by s minus 1, right? So now here 7 into L inverse of 1 by s minus 2. Again here plus L inverse of 1 by s minus 2 whole square we can write. Here minus 10 into L inverse of 1 by s minus 1. So here we can write, already we know that L inverse of 1 by s minus 2 can be written as e to the power 2t. So we can give the answer as 7 into e to the power 2t. Plus here we have to use shifting property because of s minus 2 whole square we are having. Here we can write, because of s minus 2 we can write e to the power 2t into L inverse of 1 by s square. So you can recall the property which we have already done in the previous videos. So here this is again minus 10 into e to the power t. Right, again what is L inverse of 1 by s square? It is nothing but t. So finally what is the answer is 7 e to the power 2t plus t into e to the power 2t minus 10 into e to the power t. So finally this is the solution to the differential equation, and this is y of t. So finally this is the required solution to the differential equation. Now let us see the second question. Solve y double dash plus 2 into y dash minus 3y is equal to cos t with the given condition y of 0 equal to y dash of 0 is equal to 0. That is, both the terms are 0 here. So as usual, first step is we have to take Laplace transform on both the sides so that we can directly use the linearity property and we can split it directly. So we can write like this: L of y is equal to L of cos t, right? So now we can use the appropriate formula, that is s square into capital Y of s minus s into y of 0 minus y dash of 0. So this is the formula for L of y double dash, plus 2 into formula for L of y dash is s into y of s minus y of 0 minus 3 into y of s. So this is equal to L of cos t. So now here s y of 0 as well as y dash of 0 are given as 0 here. So that here s square into y of s, these two terms become 0. Next is plus 2 into s into y of s. This becomes 0 here. That is, this term becomes 0. This term 0. This term 0. So minus 3 into y of s is equal to, now we can write the formula for L of cos t. L of cos t is what? S divided by S square plus 1. Right? Now the next step is we have to write what is y of s. So collect y of s term separately. So this is s square plus 2s minus 3, which is equal to s by s square plus 1. Now we can factorize this s square plus 2s minus 3, right, which can be splitted into s plus 3 into s minus 1. That is, this can be factorized like this. So we can write it as y of s into this is equal to s by s square plus 1. Now we have to take y of s separately. So y of s becomes s by, already s square plus 1 is here. Apart from that, s plus 3 and then s minus 1. So now the next step is we have to take inverse Laplace transform. So L inverse of s by s square plus 1, s plus 3, s minus 1. Clear? So now this gives you y of t, which is equal to L inverse of s by s square plus 1, s plus 3 into s minus 1. Now using partial fraction method, this s divided by s square plus 1 into s plus 3 into s minus 1, we can split it into as plus b divided by s square plus 1. Because this is non-linear factor s square plus 1, so we are considering the numerator as as plus b. Next is, already b is here, so we can take another constant c divided by s plus 3 plus another constant d divided by s minus 1. Okay, so for this we can go through the video for partial fraction method. So as usual, here we have to simplify to find out a, b, c and d. So if you simplify, we will get s is equal to, take LCM to the right side, into s plus 3 into s minus 1 plus c into s square plus 1 into s minus 1 plus d into s square plus 1 into s plus 3. So like this, first we have to simplify. Now here by substitution method, it is difficult to find the constants a, b, c, because for none of the value the term won't vanish, right? So what we have to do here is we can have to go by equating the like terms. So by equating the like terms, what we have is d is equal to, first let me tell you the value of a here. You can simplify and you can check it. So a is equal to minus 1 by 5, b is equal to 1 by 10, c is equal to 3 by 40 and d is equal to 1 by 8. So these things you can able to verify by yourself by using equating the like terms. Okay, or otherwise if you want, you can also go by substitution method by putting s is equal to minus 3 and s is equal to plus 1. Okay, and s is equal to 0, like that also. So which is easy for you. You can able to apply that method to get the constant value a, b, c and d. After getting this, then y of t, we can write it as L inverse of as plus b. We can split it as as by s square plus 1 plus b by s square plus 1. So what we can do here is minus 1 by 5s, this is as, divided by s square plus 1 plus L inverse of b is 1 by 10. So we can split it like this, okay, s square plus 1. So here I have split it as as by the denominator plus b by the denominator. Now we can write the third term, that is c term, that is 3 by 40 divided by s plus 3 plus again L inverse of d is 1 by 8 divided by s minus 1. Clear? So now we have to use the appropriate formula to get the required solution. So this is equal to, take minus 1 by 5 outside, it will be L inverse of s by s square plus 1. Here plus 1 by 10, L inverse of 1 by s square plus 1 plus 3 by 40, L inverse of 1 by s plus 3 plus 1 by 8, L inverse of 1 by s minus 1. Now if you look at each and every term, it is very simple to apply the formula. So minus 1 by 5 into what is L inverse of s by s square plus 1? It is cos t plus 1 by 10 into what is L inverse of 1 by s square plus 1? It is sin t plus 3 by 40 into L inverse of 1 by s plus 3 can be written as e to the power minus 3t plus 1 by 8 into L inverse of 1 by s minus 1 can be written as e to the power t. So finally, this is a required solution to the given differential equation.